So we're going to do some examples about solving rational equations. So as you watch this video, it'll be helpful if you write down stuff on your paper, and I'll also let you know at certain times to pause the video so that you can try some of the problems on your own. So solving rational equations builds on what you learned in middle school with solving proportions. So before you watch the rest of this video, if you can go ahead and pause it, and on number 1, if you can give that a try, and to solve that proportion as many ways as you can think of. All right, now that you have tried number 1 on your own, a couple common strategies that you may have thought of or may not have thought of. Firstly, cross-multiplying. So cross-multiplying is the idea of multiplying one numerator by the other denominator. So in this equation, x over 9 equals 2 over 3. If you were cross-multiplying, you would do x times 3 and then also multiply 2 times 9. So x times 3, well, that's 3x, right? And then 2 times 9, you could write it as this, or go ahead and multiply them together, which would be 18, right? So 3x equals 18. And then maybe divide both sides by 3 to get that x equals 6. So that is one strategy that you could use to solve that proportion. So I'm going to label that up here. That's cross-multiplying. Maybe the strategy that you used was noticing that, well, this 3, if you multiply it by 3, you'd get to 9. So I would call that maybe like scaling up. If you notice that, well, to get from 3 to 9, you would multiply by 3. So if you multiply the 2 by 3, that would get you the value of x. And so in doing that, well, 2 times 3 would be 6, right? So you again get that x equals 6. So I'm going to label that scaling up. That's what you could maybe call that strategy. Another option is kind of similar to that, but maybe just thinking of it as getting common denominators. So when you see this x over 9 equals 2 over 3, well, to get a common denominator, you could get this 3 to be a 9 by multiplying it by 3. And if you multiply the denominator by 3, you would also multiply the numerator by 3. So that's that convenient form of 1 that we've been talking about in class. And so then, when you multiply that, well, 2 times 3, that's 6, over 3 times 3, which is 9. So you get x over 9 equals 6 over 9. And maybe at this point you're noticing, well, okay, we've got two fractions that are equal, and the denominators are equal. So just logically, wouldn't the numerators also have to be equal, right? So if this is 6 over 9 and it's equal to some number over 9, that number would have to be 6. So like these numerators have to be equal, right? So x, again, would have to equal 6. So we are going to do a few more of these problems and building on these strategies. So I'm going to label this one like get a common denominator, right? That's what we did here. And then once the denominators are the same, well, then we know that the numerators also have to be the same. So on number 2, we're going to solve that rational equation 2 different ways. We'll focus on cross-multiplying and the strategy of getting a common denominator. So we'll start with cross-multiplying, especially since that's probably what you're most familiar with from middle school. So cross-multiply, you would multiply the 15 times the 4, but also the x minus 5 times the 5. So when you write that, it doesn't really matter which pair you write first. So this 5 times x minus 5, maybe you write that as 5 times x minus 5. And then the 4 times 15. So distribute that 5, right? That'd be 5x minus 25 equals 4 times 15, which is 60. And now that's just a 2-step equation that you could solve. So add 25 to both sides. And then 5x equals 85. And then to get x by itself, divide both sides by 5. And you would get that x equals, let's see, what would that be? And you would get 17. So x is equal to 17. And you could always check your answer by plugging in 17 back for x and make sure that the two sides of this equation really do equal each other. So we'll try this other strategy now of getting a common denominator. So if we can get both fractions to have the same denominator, then we know that the numerators would also have to be equal. So in this original problem, think about what would you want that common denominator to be? And maybe 15, right? So if we can get this 5 to be a 15 by multiplying it by 3, and just like we talked about up here, right, we're multiplying by this convenient form of 1. So that's what this allows us to do, is get a common denominator. So 4 times 3 is 12, and 5 times 3 is 15. So x minus 5 over 15 is equal to 12 over 15. And then we're back to this idea that we talked about up here. Like if we have two fractions that we know are equal, their denominators are equal, then logically we know that the numerators would also have to be equal. So x minus 5 would equal 12. And then solving that equation, add 5 to both sides, and you would get that x equals 17. So notice you should get the same answer, right, if you do it either way, since you are solving the same equation. So take a moment and maybe decide for yourself, like on this problem, did you prefer this cross-multiplying strategy, or did you prefer getting a common denominator? So on this next problem, we'll try it again using both strategies. And again, be thinking about which one seems easier and which one you would like to use more often moving forward. So we'll start with cross-multiplying again. So to cross-multiply, we know that we will need to multiply the numerator of one of these fractions times the denominator of the other, right? So we'll multiply here, and we'll also multiply here. So doing that, you could write it as, well, 7 times 3x plus 17. So 7 times 3x plus 17. And that has to be equal to 14 times 5x minus 2. And then distribute, right? Now, looking ahead, I can already see that these are going to be some pretty big numbers. Like off the top of my head, I don't know what 7 times 17 is, right? That would take me some time to think about, or I'd have to use a calculator. So cross-multiplying, kind of the downside of it is you sometimes do end up with these really big numbers. So I'm also going to set this up using our other strategy of getting a common denominator, and we can see if maybe this looks any easier. So in the original problem, do you see an easy way to get a common denominator? So maybe if both denominators were 14, that would make this problem maybe easier, we'll see. So if we multiply this fraction by 2 over 2, again, this convenient form of 1. And so when we do that, we'd have, well, 2 times 5x minus 2, which is equal to, oh, and don't forget the over 14. And then the other fraction, still 3x plus 17 over 14. So right now, we've got two equal fractions with equal denominators. So the numerators have to be equal. Like logically, that's the only way that this is truly an equation where one fraction equals the other. If the denominators are the same, then the numerators are also going to have to be the same. So then we can focus on just solving the numerator of these fractions, right? Personally, I think this looks like an easier equation to solve than this one did up here, right? So these numbers were going to turn out to be a lot bigger than the numbers in this equation. So I prefer to find a common denominator anytime I'm solving these types of equations, but cross-multiplying will also work. You just may end up with bigger numbers. So if we solve this equation down here, all right, so distribute that 2, and you would have 10x minus 4 is equal to 3x plus 17. So we've got a variable on both sides of the equal sign. So at some point during our solving process, we're going to need to bring those together. And it doesn't really matter right now what order you do things in. I mean, you can move any part of this equation around. I would probably start by go ahead and bringing those x's together. And just to keep the coefficient positive, I'm going to choose to bring the 3x over here instead of moving the 10x. So I'll do minus 3x on both sides. And then we'd have, let's see, 7x minus 4 equals 17. So add 4 on both sides, right? And then you would end up dividing by 7. So I'm running out of room here. I'm going to let y'all finish solving that equation. You should end up getting x equals 3. All right, we're going to look at number 4. So I'm going to stick with this strategy from before of getting a common denominator. So like I mentioned, this is my preferred strategy just because I know it's going to make the solving easier at the end. It's going to make the numbers a little more manageable, and you won't have to have as big of numbers as you would sometimes from cross multiplying. So looking at this problem, first think about, okay, well, what do you want the common denominator to be? So, you know, in this last problem, we multiplied one of the fractions by 2 over 2 so that we could get that denominator to be 14, the same as the other denominator. Here, we're going to end up having to multiply both fractions by something. So maybe you're noticing that 15 could be a good common denominator. So that would require multiplying this fraction by 3 and multiplying this fraction by 5. So over here, if we multiply numerator and denominator by 3, right? Oops. And then over here, multiply numerator and denominator by 5. So finding these convenient forms of 1 is what lets us get a common denominator. So you could write this as, well, 5 times 3x plus 6, right? So there's the 5 times the 3x plus 6. You could go ahead and distribute those in this step if you wanted to. And then 5 times 3 would be 15. And then over here, we're going to have 3 times the 4x minus 1. So 3 times 4x minus 1 over 15. And then we're back to this place where we have 2 equal fractions with equal denominators. So then we know that these numerators have to be equal. And so now you can solve this equation. 5 times 3x plus 6 is equal to 3 times 4x minus 1. Right? So to solve that, you're going to need to distribute. And then, like we talked about in this last problem, there is going to be a variable on both sides over here. So you will need to bring those two variables together to be able to isolate the x and be able to solve for it. So I encourage you to pause the video here so that you can finish solving this equation. Just a heads up, you should get -11 for x. So if you don't get that, maybe go back and check your work and see if you can find a mistake. All right, now that you have finished the front side, we're going to take a look at the back and we're going to do some of these problems together, and then you're going to have a chance to try a few. So on the back, number 5, you may notice that, well, we've got a fraction plus a fraction is equal to another fraction. So let's say you're thinking about cross multiplying, which was a strategy we looked at in the front. So think in your head about, well, what would you actually cross multiply in this problem? Because you've got 2 things being added together over here. Also, if you get a common denominator, well, that looks pretty doable, right? So we can get the denominators to be 15. But then we're going to need to add these 2 fractions together before we can use either of the strategies. So whether you're cross multiplying or finding a common denominator, we need to add the 1/3 with the x plus 5. So to do that, we know we need a common denominator, right? Because when we're adding and subtracting fractions, they need to have the same denominator. So similar to what we did on the last problem, multiplying this x over 5 by 3 over 3 All right, so that's our convenient form of 1 once again. Sorry, that's a sloppy 1. And then over here, multiplying numerator and denominator by 5. So 5 times 1, that's 5 over 15. And then add that to, well, x times 3, or you could write that as 3x over 5 times 3 again, 15, equals 11 over 15. So now, since these two fractions have the same denominator, we can add the numerators together. So we can't actually combine the 5 with the 3x, since those are not like terms, but we can write that still. It's just, 5 plus 3x over, and then that common denominator stays the same. All right, so it's still a 15, equals 11 over 15. So at this point, you can either cross multiply, right? So multiply 15 times that and 15 times 11, and then solve that equation. Or if you prefer working with smaller numbers, right? If the denominators are equal, then so are the numerators. And so we can solve this equation, this 5 plus 3x equals 11, right? So to solve that, subtract 5 on both sides. And 11 minus 5 would be 6, right? 5 minus 5, that's 0. So 3x equals 6. Divide both sides by 3. And you get that x equals 2. All right, we're going to look at another one. So on number 6, it's got variables in the denominators. So as we start thinking about finding a common denominator, we'll have to consider the variables as well. So just like when we talked about on number 5, we had to add these fractions together before we could do any sort of solving. So same idea over here. We're going to need to subtract these two fractions before we can either cross multiply or solve it by getting common denominators. So we need to be able to subtract, we need a common denominator. So we've got a 3x squared in this denominator and another 3x squared here, but only an x squared in this one. So this one's going to need to be multiplied by 3. So we're going to multiply this fraction here by 3 over 3. Right? So that just is equal to 1. So that fraction, well, 1 times 3 is just 3. And then x squared times 3 would be 3x squared. So let me rewrite the rest of this. So 12 over 3x squared is equal to x minus 6 over 3x squared, and then minus the 3 over 3x squared. So then we can subtract numerators here. So this 12 over 3x squared, we haven't touched anything with that yet. But here we can do x minus 6 minus 3, or we can go ahead and combine the negative 6 and the negative 3, which would be negative 9. So that numerator would become x minus 9 over 3x squared. And then you decide, you can cross multiply. If you notice, you are going to end up with an x squared times an x, which is going to be x cubed. Maybe you want to avoid solving an equation that has an x cubed in it. So since the denominators are the same, maybe you choose to solve just the numerators. So this 12 would be equal to x minus 9. And now that's just a one-step equation to solve. So add 9 on both sides, and x would be equal to 12 plus 9, which is 21. All right, on number 7, I'm going to kind of help you get started and then let you finish that one and do numbers 8 and 9 as well. So on number 7, start thinking about what you might want those denominators to be if we're trying to get all 3 fractions to have the same denominator. So one of them's got just an x, one's got an x squared, one's got a 3x. So if we can get all denominators to have a 3 in them, and maybe we can get all denominators to have an x squared. So our goal is going to be to get all denominators to be 3x squared. So got to think about what to multiply each fraction by then. So this fraction, if we want that to be x squared, we need to multiply it by another x. So if we multiply this fraction by x over x, and multiply this fraction by 3 over 3, so we can get the denominator to be 3x squared. And then over here, well, it's just an x, so if we want it to be 3x squared, we need to multiply by 3x over 3x, right? Which is still just another convenient form of 1. All right, so now multiplying this stuff together. So to start with, 3x times 2, which would be 6x, over 3x squared, plus, well, 5 times 3 is 15 over, and then the 3 times x squared is equal to, and then 1 times x, or just x, over, and then 3x times x, or 3x squared. So now you can add these two fractions together. So 6x plus 15 in the numerator over 3x squared is equal to x over 3x squared. So I'm going to stop here and let you finish solving that. So at this point you could solve just the numerator of that and figure out what x would equal. And then when you finish that one, give numbers 8 and 9 a try. Just a reminder, you have a test next class. On that test, it is not going to be solving, so it's not these types of problems on this paper. It's going to be multiplying and dividing rational expressions, but also adding and subtracting rational expressions. So if you can do on number 7, just this first part here of getting those two fractions added together, and then if there is anything that simplifies, like that's the kind of stuff that will be on your test next class. You will not actually have to solve for x.